and welcome. Today we're going to dive into Nutrition and Metabolism 101. So whether you are an advanced nutrition practitioner or you are a clinician that's really seeking to understand nutrition and metabolism at a deeper level so that you can help your patients really thrive, then this is for you. My name is Dr. Arianne Missimer. I'm a doctor of physical therapy, registered dietitian, and functional medicine practitioner. I'm the owner of the Movement Paradigm Integrative Health Center, and I'm also a medical educator for Rupa Health. So we know that there's so much misinformation about nutrition. And so today we're going to talk about nutrition as a science, not as an opinion. So we're going to dive into the 6 major essential nutrients. We're going to talk about digestion, absorption, transport, and cellular respiration. And let's start with what is nutrition. So nutrition is the science that studies the interactions between living organisms and their food. It encompasses the intake of food, absorption, assimilation, biosynthesis, catabolism, and excretion. And it is critical for maintaining health, growth, reproduction, and overall well-being. It is one of the most foundational things that we need to support us through our lifetime. And what are some of the key aspects of nutrition? So let's touch on some of these, which we'll dive into a little bit deeper as we go. Macronutrients, which are going to be required in larger amounts, including our main energy sources such as carbohydrates, proteins, and fats. And they're essential for the structure and function of our cells, tissues, and organs. We have micronutrients required in smaller amounts, such as vitamins and minerals, and these are going to play crucial roles in various biochemical reactions. They act as cofactors for many pathways in the body, and this is going to influence immune function, bone health, and energy production. Water is going to be one of the most essential nutrients, and normally we're most deficient in. For all forms of life, it's involved in various bodily functions, including temperature regulation, waste removal, and nutrient transport. Then we have dietary fiber. So this is going to be found in our plant foods. It's aiding in digestion, so extremely important for our gut health. Short-chain fatty acids. It helps to prevent constipation. And remember that having healthy bowel movements is one of the key ways that we are detoxifying. It plays a role in maintaining healthy blood sugar and cholesterol levels as well. And then we have our phytonutrients and antioxidants. So these are compounds that are found in plants that have extremely health-promoting properties, helping to reduce inflammation and protect against chronic disease. So as it relates to proper nutrition, although there are a lot of different opinions about this, it ultimately involves a balanced diet that provides all of the essential nutrients to support your body's needs or your patient's. This can include a variety of fruits, vegetables, grains, healthy fats, lean proteins, and it is going to be highly individualized. It's going to be based on your genetics. It's going to be based on your activity level, your food preferences, your cultural background. It's going to involve so many different aspects of your patient that we want to make it as highly individualized as possible, recognizing that it is going to also ebb and flow across your lifetime. So, for example, you may start off your patients with a therapeutic food plan, but that should have a start date and an end date. So if they are doing an elimination diet, they might be doing it for 3 to 6 weeks, reintroduce, and move into a healthy, balanced diet for them. If it's a low FODMAP plan, they might be on it for 6 weeks and once again transition. So we want to be really intentional about creating balance in our patients' lives and really supporting a healthy relationship with food. Now let's move into the complexity of digestion. So we're going to talk about 2 physiological aspects of digestion, the mechanical and then the chemical. So when we're referring to mechanical digestion that's going to happen in every phase of digestion, we're thinking about the maceration, the churning, the movement, our chewing, our swallowing, anything that grinds the food down and helps it to move through the digestive tract, allowing for optimal chemical digestion. So what does chemical digestion involve? This is going to involve fluids, enzymes, biochemical reactions, and these are generally stimulated by the nervous system signals, particularly the vagus nerve, also hormones and mechanical stimuli. So the first phase of digestion is called the cephalic phase. So this actually happens before we even take our first bite. So this is where we're smelling food, we're seeing food, and this is beginning to start the process where our brain is starting to recognize that we have to get ready to digest our food. So it's signaling to the salivary glands in your mouth to prepare to eat. It's secreting saliva to begin the breakdown of food. So again, the eyes and nose are going to send stimuli to the brain and brainstem, and many of these signals, as I mentioned, are mediated by the vagus nerve and its efferents and afferent fibers. Next, we have the oral phase. So this is going to involve mechanical breakdown of food, which is going to be the chewing and swallowing. So as we chew our food, ideally 20 to 30 times, we are beginning this mechanical breakdown of carbohydrates into simpler sugars. As it relates to chemical breakdown, we have our saliva that's going to contain special enzymes such as amylase and linguinal lipase. Amylase, which is going to help to break down our more complex starches into simpler sugars. And then we also have our linguinal lipase that's going to break down fats. When we have our swallowing, we're going to have our tongue that is going to help to push the food into the throat, ultimately into the esophagus. And so we have this, once again, combination of mechanical and chemical digestion. Now, there's a huge vagus nerve influence in this bidirectional communication of gut and brain. And so when we look at the afferent information, we have 90% of that information that's coming from the gut to the brain. This is going to involve things like inflammation, satiety, energy metabolism, but we also have 10% of those efferent fibers going to the gut, which is going to involve secretion of gastric and digestive enzymes and gastric capacity. So it's really important to consider both of these. And so as it relates to digestion as a whole, we want to really encourage a rest and digest state, ensuring that our patients are calm before they're eating so that they can really maximize each phase of digestion. So now we'll move into the gastric phase. So as it relates to the mechanical breakdown, we want to think of the peristalsis, the mixing and propulsion. And as it relates to the chemical breakdown, once the food is coming down through the esophagus, it reaches the stomach, it's going to mix with gastric juices. And so think this is hydrochloric acid and pepsin, which is really important for protein digestion. And the stomach is going to ultimately churn the food into a semi-liquid substance called chyme. And really important because this is so often a possibility in our patients that have low stomach acid. So they're not breaking down their proteins. They're not absorbing the amino acids from their proteins. They have B12 deficiencies. They may have iron deficiencies. So this phase is extremely important and also goes back to our initial phases of digestion as well as that vagus nerve influence to make sure that we are really optimizing digestion. Once the food is coming to the stomach, now it's moving to the small intestine. So here a lot of things happen. So chyme is going to be gradually released into the small intestine, and this is where most of our digestion and absorption of nutrients is occurring. So it's going to meet with bile from the gallbladder. So think the liver is producing the bile, the gallbladder is storing the bile, and it's going to help to release the appropriate amount of bile when you are eating a certain amount of fat. So it's going to help to emulsify that fat. It's meeting with the pancreatic juices. So that's where the pancreas is going to release in the exocrine gland, is going to release pancreatic juices. This is going to help further break down carbohydrates, proteins, and fat. And this is where nutrient absorption happens. This is where the magic happens. So the walls of the small intestine are lined with tiny-like structures, hair-like structures called villi and microvilli. And this is what helps to absorb nutrients into the bloodstream. And then these nutrients are transported to different parts of the body for use. Now we have the large intestine phase. So think after everything happens in the small intestine, now as it moves into this large intestine, we have our water absorption. So the remaining substance, which is now at this point largely devoid of nutrients, is going to move into the colon. So the main job here is to absorb water and some minerals. It's turning the liquid chyme into a more solid form of waste. Although there's no real specific chemical digestion that's happening here, there is a huge influence of the bacteria because this is where most of our bacteria in our digestive tract exist, as compared to the small intestine where we have a small amount of bacteria. So for example, if we have a small bacterial overgrowth, that's when it becomes a problem. And then lastly is the elimination phase. So this is our excretion. So this is where the solid waste that is stored in the rectum is going to be expelled through the anus during a bowel movement. And lastly, let's not forget the liver's role in the digestion process. So this is really going to be extremely important for metabolism and detoxification. So it's not directly in the path of digestive tract. Again, we want to remember that the liver is producing the bile, but the liver is playing a crucial role in processing the nutrients that are absorbed from the small intestine via the portal vein. So the blood-carrying nutrients are going to pass through the liver. They're metabolized, they're stored, they're detoxified, and they're transformed into energy or building blocks for other processes of the body. So the liver also helps to process fats and produce cholesterol. So it's an extremely huge role. We are going to tackle that, but I do want to recognize the liver's role throughout this process. So now let's touch on the absorption process. So we have carbohydrates that are broken down into monosaccharides, in particular glucose being the most prominent monosaccharide, but we also have galactose, mannose, fructose, and ribose, which are also of biological importance. These are absorbed by active transport into the bloodstream. We also have our proteins, or other macronutrient. These are broken down into amino acids, absorbed by active transport and facilitated diffusion into the bloodstream as well. Then we have our fats. So our fats are going to be broken down into fatty acids and glycerol. They're reassembled into triglycerides. They are packaged into chylomicrons and transported via the lymphatic system into the bloodstream. So as it relates to our nutritional states, we have our absorptive state, which is during and after eating. And then we have our post-absorptive state, which is when the GI tract is empty, but the body is using stored energy. And so we have hormones such as insulin, which is going to lower blood sugar, blood glucose levels. And we have glucagon, which is going to raise blood glucose levels. And it helps to regulate these particular states. So in the absorptive state, think of you're going out to eat, you have a big meal, and you're kind of unbuckling your pants because you're so full. So when we are in this fed state, this is happening during or after you eat. So during this time, your body is busy digesting and absorbing the nutrients from your meal, mainly in the form of glucose. So any excess glucose that your body does not need, so beyond what your cells need in that immediate state for energy, that will get stored later as fat or glycogen. So this is the body's way of preparing for times when you will not be eating, you won't be in a fed state, such as between meals as well as sleeping. So when we think about our basal metabolic rate, how much energy gets stored really depends on your basal metabolic rate. So the number of calories your body needs to do your basic activity during the day, your business as usual. So essentially, it's the number of calories needed for basic functions. It's influenced by your age, by your sex, your body size, your composition, ultimately even your activity level. Your higher BMR is going to mean you're burning more calories at rest. So of course, if we're looking at a young bodybuilder compared to an elderly woman, the energy expenditure is going to be entirely different. So that is really important for us to appreciate. So now, as it relates to insulin regulating blood glucose, glucose is the easiest source of food for our cells, like our neurons, like our brain, for example. And our body likes to maintain a blood glucose level of 70 to upwards of 100 milligrams per deciliter. So insulin is going to lower blood sugar by promoting glucose storage at times that we need to. It's going to prevent high blood sugar levels, which can ultimately create a lot of damage. If we think of diabetes, and the prolonged higher level glucose levels are going to create a whole host of complications, including things like ultimate amputations. So insulin's job is to move glucose out of the blood and into storage, so it puts a stop to glycogenolysis, or breaking down glycogen in your liver and muscles to release glucose for energy. So it basically stops the catabolic reaction and it turns into an anabolic reaction. So instead, it ramps up the process of glycogenesis, which is where extra glucose is linked together to form glycogen. So it also activates lipogenesis, which is where chemical reactions in the liver convert glucose into triglycerides and then ship them off to your adipose tissue for storage. So it's a really fascinating and complex process. And then we have our lipoproteins. So our lipoproteins are going to transport lipids in the blood, and we have our LDL cholesterol, our HDL cholesterol. Our LDL cholesterol is going to contribute to storing fat, and HDL cholesterol is going to contribute to removing excess cholesterol. So essentially, LDL is what delivers some of the glucose and fat that you just ate into your body's fat deposits. HDL starts out as an empty protein packet sent out by the liver to gather up cholesterols from the blood, the artery walls, and other cells. And then it's delivering the cholesterol back to the liver or places like the ovaries, testes, adrenal glands, which it's used to make steroid hormones. So, of course, lipoproteins are extremely helpful in healthy steroid function. So in the postabsorptive state, we are relying mostly on stored glycogen and fats for energy. So glucagon is going to raise blood sugar by breaking down glycogen. When we have insulin diabetes, a lack of insulin is going to result in higher blood sugars and reliance on fat and protein for energy. So it really goes to show the importance of helping our patients manage their blood sugar levels. So as it relates to transport to the cells, we have glucose that is transported to the cells via glucose transporters, and insulin is going to help to regulate the uptake of that. We have amino acids that are transported to cells for protein synthesis or energy production. And then we have our fatty acids and glycerol that are transported as chylomicrons to cells for energy production or storage. So now that we've talked about digestion, absorption, and transport of nutrients, let's talk a little bit about metabolism before we dive into the 6 different essential nutrients. So metabolism, we commonly think of as how fast your body can burn fuel or how high your personal energy is. What we want to think of as metabolism is the sum of all chemical reactions that occur within a living organism to maintain life. So it's a pretty powerful process. It involves every biochemical reaction in the body, and it's based on the law of conservation. So energy can never be created or destroyed. It can only change forms. So with that, we are going to have 2 distinct processes that are happening all of the time: anabolism and catabolism. So anabolic reactions are going to essentially construct molecules and consume energy. So we're building complex molecules from simpler molecules like proteins and fats, and it is essential for growth, repair, and storage of energy. Anabolic processes require energy, which is typically provided by ATP, which is adenosine triphosphate. So we essentially have things like protein synthesis, which is the creation of proteins from amino acids. We have DNA synthesis, the replication of DNA molecules from nucleotides. We have glycogen synthesis, the storage of glucose molecules as glycogen in the liver and the muscle. Then we have our catabolic reactions. So this is going to involve the breakdown of complex molecules into simpler ones, releasing energy in the process. So this energy is going to be used to fuel various cellular activities and generate ATP. So some examples of this are digestion and cellular respiration, which we're going to talk a lot about. So glycolysis is going to be the breakdown of glucose into pyruvate, yielding ATP and NADH. We have beta oxidation, which is the breakdown of fatty acids into acetyl-CoA. And then we have protein degradation, which is the breakdown of proteins into amino acids. So there's a really amazing relationship between the anabolism and catabolism to ultimately regulate the body's energy balance and availability of essential molecules. So first we have energy flow. So energy released from the catabolic reactions is used to drive anabolic reactions. So for example, ATP during the breakdown of glucose and glycolysis, which is catabolic, is used to synthesize proteins, which is anabolic. So there's this constant building and breaking down. And so while these catabolic pathways are constantly breaking down nutrients and cellular components to release energy, we are also having the simultaneous anabolic pathways that are building blocks to create and construct new cellular components such as proteins, nucleic acids, and cell membranes. We also have this balance and regulation. So the balance between anabolism and catabolism is tightly regulated by hormones and other signaling molecules that ensures that the body meets its energy needs and maintains homeostasis. So of course, that is what we're always striving to do in our bodies, is maintain homeostasis. So for example, insulin is going to promote an anabolic process such as glycogen synthesis and protein synthesis, where glucagon and epinephrine are promoting catabolic processes such as glycogenolysis and lipolysis to increase blood glucose levels. So now let's transition into the essential nutrients. So this is the materials your body needs to build, maintain, and repair itself. We're going to talk about 6 major groups of essential nutrients. We have water, vitamins, minerals, carbohydrates, lipids, and proteins. So we're going to start with water. So this is our most vital nutrient. It constitutes the majority of the body's volume, and it is essential for all biochemical reactions. We do want to encourage our patients to have at least half of their body weight in ounces a day of water, but this, of course, can be dependent on a multitude of factors, such as the heat and environment, how much they're sweating, the activity, and so on. The next is going to be vitamins. So we have our fat-soluble vitamins, and we have our water-soluble vitamins. It's important for aiding in all of our metabolic reactions. So we want to think about our vitamins being extremely essential cofactors for numerous reactions in the body. So when we're looking at our water-soluble vitamins, so this is going to dissolve in water and they are not stored in the body. So this is essentially going to be our B and C vitamins. They must be consumed regularly because of this. And we have our different B vitamins. We have B1, which is thiamine. So this is essential for energy metabolism and nerve function. We have B2, which is riboflavin, which is important for energy production and skin health. We have vitamin B3, which is niacin. This is helping with DNA repair and energy metabolism. We have B5, which is pantothenic acid. This is vital for fatty acid synthesis and energy production. We have B6, which is pyridoxine, which is crucial for amino acid metabolism and red blood cell production. We have B7, which is biotin, which is important for carbohydrate and fat metabolism. We have B12, which is cobalamin, and this is essential for nerve function and red blood cell formation. And then we have our vitamin C, ascorbic acid, which is important for collagen synthesis, antioxidant function, and immune health. So now we'll go into our fat-soluble vitamins, A, D, E, K. So we have our fat-soluble vitamins that are stored in the body's fatty tissue and liver. They're going to include, as I mentioned, vitamin A. So this is going to be essential for vision, immune function, and skin health. This is going to be found in foods like carrots, sweet potatoes, and liver. We have vitamin D, which is important for calcium absorption, as we know, bone health, and immune function. It's found in fortified dairy products, fatty fish, and of course it's synthesized in the skin upon sun exposure. Vitamin E, which is going to act as a powerful antioxidant. It protects cells from damage, and it is found in nuts, seeds, and vegetable oils. And then we have vitamin K, which is necessary for blood clotting and bone health, and it's found in green leafy vegetables, broccoli, and Brussels sprouts. Our B vitamin sources are going to come from mostly animal proteins. So this can be things like meats, seafood, dairy products, but it can also be in things like nuts and seeds and even some fruit to an extent. And then our vitamin C foods are going to be things like broccoli, kale, some of our citrus fruits, and berries. So minerals are inorganic elements that are essential to the body's functioning. They're found in soil and water, and they enter the food chain through plants and animals. So we have lots of different examples of how minerals have a crucial role in the body's functioning. For example, bone health. So calcium and phosphorus are crucial for maintaining and building strong bones and teeth. We have energy production, which magnesium, which we know has over 700 different roles and reactions in the body, plays a key role in energy production and metabolic processes. We have immune function, so zinc specifically supports immune system function and even wound healing. We have oxygen transport, so iron is essential for the formation of hemoglobin, and that's going to carry oxygen in the blood. Then we have fluid balance, so sodium and potassium help to maintain this fluid balance and are crucial for nerve and muscle function. And then we have enzyme function, so many minerals are going to act as cofactors for enzymes, so that also helps to aid in different biochemical reactions in the body. And as long as our patients have a balanced diet that has a variety of foods, including a variety of fruits and vegetables, you most likely are going to get an adequate intake of these essential minerals. But it is important to recognize that depending on the water that you're using or your patients are, you may need to supplement with additional minerals, especially if they do not have a balanced diet. So now let's talk about our main source of energy, our carbohydrates. So these are organic compounds that are comprised of carbon, hydrogen, and oxygen. So as a nutrient, they can be classified into two different groups, which are simple carbohydrates and complex carbohydrates. So our simple carbohydrates, we want to think of as simply referring to sugar. Those that are readily digested into the bloodstream provide a rapid source of energy. Conversely, our complex carbohydrates, such as cellulose, starch, and glycogen, are those that are going to need more time to be digested and metabolized. They're often higher in fiber, and unlike the simple carbohydrates, they're less likely to cause that rapid spike in blood sugar. So now let's break this up a little bit further into monosaccharides, disaccharides, and polysaccharides. So monosaccharides, think, is glucose. This is going to come from fruits, honey, and sugar. And we have our structure of our monosaccharides, which is very basic. So this is going to include the carbon, hydrogen, and oxygen atoms, and it could range anywhere from 3 to 7. We have different types of monosaccharides that are going to come in the form of glucose, fructose, and galactose. So glucose is an essential energy source for cells, and it's going to be found in fruits, vegetables, and honey. We have fructose, which is going to be the sweetest natural sugar found in fruits, honey, and also root vegetables. And then we have galactose, which is less sweet. It's commonly found in combination with glucose to form lactose. And the function of our monosaccharide is crucial for providing energy. So they are absorbed directly into the bloodstream during digestion and are immediately used by the cells for energy. So this is the be-all, end-all molecular fuel that your cells need to make ATP. And ultimately, the cells are going to use ATP for anabolic reactions. So whether it is operating a sodium-potassium pump, it's detaching the head of a myosin filament to contract a muscle, it is crucial for so many anabolic reactions in the body. Next, we have disaccharides. So this is going to be composed of two monosaccharide molecules linked together by a glycosidic bond, and they're broken down into their monosaccharide components during digestion. So the structure of a disaccharide is going to consist again of two monosaccharides joined by a covalent bond, usually formed by a dehydration reaction, so a removal of a water molecule. The types of disaccharides are sucrose, lactose, and maltose. So sucrose is commonly known as table sugar, and it's composed of glucose and fructose, and it's found in many plants, especially sugarcane and sugar beets. We also have lactose. So this is known as a milk sugar composed of glucose and galactose. It's found in milk and dairy products. And then we have maltose, which is known as a malt sugar composed of two glucose molecules. It's formed during the breakdown of starch and found in malted foods and beverages. So ultimately, the function of disaccharides are again a source of energy. During digestion, enzymes are going to break down disaccharides into their monosaccharide components, which are then absorbed into the bloodstream for energy. So lastly, we have polysaccharides. So these are complex carbohydrates composed of long chains of monosaccharides bonded together. So they're going to consist of hundreds and sometimes even thousands of monosaccharides linked by a glycosidic bond. So the structure essentially is a polymer of monosaccharides. There are three different types. So there's the starch, glycogen, and cellulose. Starch is going to be a storage polysaccharide in plants composed of glucose units. So it's found in foods such as potatoes, rice, and corn. It's broken down into glucose during digestion to provide energy. We have glycogen, so our stored polysaccharide in animals, also composed of glucose units. It's stored in the liver and muscles and is broken down into glucose when the body needs energy. Cellulose is a structural polysaccharide in plants. It's composed of glucose units linked in a way that humans cannot digest. So it's found in cell walls of plants. It does provide dietary fiber, and of course that can aid in digestion and overall gut health. So the functions of polysaccharides are going to serve various functions in the body depending on their type. One is going to be energy storage, so starch and glycogen can serve as energy reserves in plants and animals, respectively, and structural support. So cellulose provides structural support to plant cell walls and dietary fiber for humans. So as it relates to carbohydrates, we want to remember that ATP is too unstable to store. So cells are often going to store energy in the form of glucose, which then they can catabolize and convert to ATP when needed. So some cells get energy from fats, but many, like red blood cells and neurons, feed exclusively on glucose. So most of the carbs that are absorbed in the intestine are converted into glucose. If it's not needed right away, that energy is going to be stored as glycogen in the liver and muscles, or it's converted to glycerol and fatty acids to make triglycerides. So the recommended daily allowance for carbohydrates is 130 grams per day. This is based on the amount of carbohydrate that's required to provide the brain with adequate glucose. Now, we do want to keep in mind that this could vary greatly depending on the person, their current medical conditions, what your specific goals are, their ability to metabolize carbohydrates. So there's a lot of factors that would go into this decision, but we do want to base it off of this general recommendation of 130 grams per day, and then you could make specific changes or recommendations based on the person that you're working with. So next we'll move into lipids. So this is another energy source. It's going to be very important for energy storage of fat-soluble vitamins like A, D, E, and K that we reviewed, insulation, and cell structure. It also is really important to help form the myelin sheath that insulates the neurons in the brain and throughout the body, and as well as create oil for our skin and provide vital calorie nutrient for breast milk. There's going to be three key types, which are the triglycerides, phospholipids, which is going to help to form the cell membrane in every cell that you have, cholesterol, which is a really important precursor for our sex steroids, like testosterone and estrogen. And then we also have our essential fatty acids, things like omega-6s, omega-3s, even omega-9s. This is where your body cannot make them, so they do have to be ingested. So let's start with triglycerides. This is going to be the most common type of fat found in the body, and it's composed of 3 fatty acids bonded to a glycerol molecule. So the functions of triglycerides are 1, to provide energy storage. This is stored in adipose tissue and used as a major energy reserve. It's also important for insulation and protection. So it helps to insulate the body and protect our vital organs, which is extremely important. It's also a source of fatty acids. So during fasting or exercise, triglycerides can be broken down to provide fatty acids for energy production. And the sources of triglycerides can be things like oils, butter, and of course other different types of fats in the diet. Now we'll move into phospholipids. So this is the major component of cell membranes. It consists of 2 fatty acids, a glycerol molecule, and a phosphate group. So the functions of phospholipids is cell membrane structure, which is going to be forming a bilateral structure of cell membranes that provides fluidity and integrity for the cells. It also is very important for signal transmission, so it provides a role in cell signaling and communication, and emulsification. So in the digestive system, the phospholipids are going to help to emulsify fats, aiding in digestion and absorption. And so some of the sources of phospholipids can be things like egg yolks, soybeans, and other foods that are rich in fat and oils. And then we have cholesterol. So this is a sterol, which is a type of lipid with a complex ring structure. It's found in animal cell membranes, and it's essential for a lot of different bodily functions. Some of these key functions include cell membrane structure. So cholesterol helps to maintain, again, the fluidity and stability of cell membranes. It is extremely important for hormone production. So when we're thinking of hormone balance, it is critical to be thinking of cholesterol. It's a precursor for the synthesis of steroid hormones such as estrogen, testosterone, and cortisol. And it's also important for bile acid formation. So it can be used to produce bile acids, which is going to be really important for digestion and absorption of our fat, and vitamin D synthesis. So it's a precursor for synthesis of vitamin D when the skin is exposed to sunlight. So some sources of this are going to be animal products like our meats, our dairy, our eggs, And the body can also synthesize cholesterol endogenously as well, essential fatty acids. So these are types of polyunsaturated fats that the body cannot synthesize on its own. So it has to be obtained through the diet. There's two main types that we're going to talk about today, which is omega-3s and omega-6s. So omega-3s are going to be crucial for brain function, heart health, and reducing inflammation. The key types are ALA, which is found in flax seeds, chia seeds, and walnuts. We have EPA, which is found in fatty fish like salmon and mackerel. And then we have DHA, which is found in fatty fish and is essential for brain health. So the functions of our omega-3s are to support cardiovascular health, reduce inflammation, and promote brain development and cognitive function. Our omega-6 are also important, although we typically do have an imbalance with these. So omega-6s are really important in growth and development. They're helpful in the inflammatory response. The key types here are LA, which is linoleic acid, which is found in vegetable oils like safflower, sunflower, and corn oil. And then we have arachidonic acid, which is found in meat, eggs, and dairy products. The functions of these omega-6s are to promote skin and hair growth, maintain bone health, and regulate metabolism. So as I mentioned, there's often a significant imbalance where we typically have more omega-6s in the diet and less omega-3s. So ultimately, we're really striving for maintaining a balance between the omega-3s and 6s to really optimize overall health. The typical Western diet is going to be heavy in omega-6s, which can often promote inflammation. They can be more pro-inflammatory if it is not balanced with a sufficient intake of omega-3s. So in order to really optimize and support heart health and reduce inflammation and promote overall well-being, we really are seeking a balance of this. So again, those omega-3s are going to be our fatty fish primarily. That's really important, at least twice a week. Our flax seeds, our chia seeds, our walnuts, and then our omega-6s are going to be more of those vegetable oils and also nuts and seeds. So as it relates to the RDA for fats, oftentimes it is recommended around 28 to 35% of the total caloric intake, and that can be more geared towards around 30%. Now, with this said, this can vary significantly, once again, depending on who the patient is, what their specific goals are, what medical conditions are they aiming for. For example, if you are doing a mitochondrial food plan or a ketogenic diet, then this would require a very high fat proportion and low protein and very low carbohydrates. So this is a general recommendation just so that you can have a guideline for your patients. Next up is protein, which is our last macronutrient, and to me is one of the most important. Our body is really made primarily of protein. Outside of water, it is 16% of our total body volume, and we are also running on protein. So it forms the building blocks of our muscles and tissues. It forms the ion channels and pumps. It also is going to help to produce enzymes, which is so critical because these are responsible for almost every biochemical reaction in the body. It's made up of 20 amino acids. 9 of them are essential, meaning that we have to obtain those from the diet. And the foods that contain protein are going to be our animal proteins, so things like our meats, our seafood, our dairy products, and our eggs. But we can also get those from plant foods such as nuts, legumes, and even other fortified foods. What's fascinating about protein is that your DNA knows exactly what amino acids to put together in what order to make a specific protein. So let's say you consume a hamburger, for example. The protein actin in the meat is going to get catabolized into its component amino acids. This is going to get mixed up with the other proteins, such as collagen, elastin, myosin, and even the proteins coming from the bun, the tomato, etc. So these amino acids are going to get reassembled using anabolic reactions, using your own proteins as defined by your DNA. So each cell has to have every amino acid needed, every ingredient present, essentially, before it will work or even begin to think about starting to make a protein. So your cells can improvise, and so if there is a missing amino acid, it can convert some amino acids into what it needs. But however, there are 9 essential amino acids that you cannot get from others. and you have to ingest them from your diet. So lots of foods do provide all of our amino acids, like our animal proteins. However, things like beans, you would have to consume an additional food like rice to make a complete protein. So the 9 essential amino acids, as I mentioned, cannot be synthesized by the body and must be obtained from the diet. So these include histidine, which is important for growth, repair of tissues, and production of histamine. Isoleucine, which is involved in muscle metabolism and immune function. Leucine, which stimulates muscle protein synthesis and supports tissue regeneration. Lysine, which is important for essential protein synthesis, hormone production, and calcium absorption. Methionine, which is important for metabolism and detoxification, also a precursor to cysteine. Phenylalanine, which is a precursor for neurotransmitters like dopamine, epinephrine, and norepinephrine. Threonine, which is important for collagen and elastin production and immune function. Tryptophan, which is a precursor for serotonin, regulates mood and promotes sleep. And valine, which stimulates muscle growth and regeneration as well as energy production. Then we have our non-essential amino acids. So these can be synthesized in the body, and they include alanine, which is involved in glucose metabolism, energy production. Arginine, which is important for wound healing, immune function, and hormone release. Asparagine, which is necessary for protein synthesis and metabolic regulation. Aspartic acid, which plays a role in the citric acid cycle and neurotransmitter synthesis. Cysteine, which is important for protein structure and antioxidant function. Glutamic acid, which is a key neurotransmitter involved in cellular metabolism. Glutamine, which is important for immune function and intestinal health. Glycine, which is important for protein synthesis and neurotransmitter function. Proline, which is crucial for collagen synthesis and wound healing, and serine, which is involved in metabolism and neurotransmitter synthesis. And lastly is tyrosine. It's a precursor for neurotransmitters and hormones such as dopamine and thyroxine. I love showing some specific graphics to my patients as it relates to how these really play a role in their overall health and why it is so critical that they are getting in these amino acids in their diet. A great example is looking at something like serotonin. So if someone is experiencing anxiety or depression or any kind of mood dysregulation or sleep issue, it is really important for them to understand and appreciate how what they eat can greatly impact these specific neurotransmitters. So for example, serotonin is going to start with tryptophan, and we need specific vitamins and minerals such as calcium, folate, copper, to make 5-HTP. Then we need magnesium, we need zinc, vitamin C to make serotonin. We need magnesium and zinc to make N-acetyl serotonin, and then we need B12 and folate to make melatonin. So it's a great visual to really appreciate the complexity of these biochemical reactions and why food is so critical in how we are functioning. Same thing as it relates to GABA. So it's going to start the process with protein ingested through our diet. It's going to help with making that stomach acid. So we need specific nutrients to even make stomach acid, like some of our B vitamins and zinc. We need glutamine, another amino acid, to make glutamate, and then ultimately to make GABA. And then lastly is dopamine. So same idea as we need phenylalanine, we need tyrosine. So we need these specific proteins that are going to help ultimately convert to dopamine, epinephrine, and norepinephrine. And so as it relates to the recommendation for protein, we want to think about the International Protein Board's recommendation because the recommended dietary allowance, the RDA, is actually set quite low for many people that are seeking to just simply maintain or even just survive. So that is set at 0.8 to 0.85 grams per kilogram of body weight. But really what we want to begin to think of is, so for general health, we want to look at 1.1 to 1.4 grams per kilogram, general exercise and fitness, 1.4 to 1.8, healthier weight loss, really referring to fat loss specifically, and recognizing that if we're in a calorie deficit, we need higher protein values. This is so critical to preserve every ounce of muscle that our patients have. This would be 1.4 to 1.6 grams. Healthy aging, 1.4 to 1.75. We know that as we're getting older, we need more protein, not less. And for advanced sport and performance and muscle building, we want to think about 1.8 to 2.2. And really, this is a closely equivalent to 1 gram per pound of body weight. So I hope you can appreciate the power of these essential nutrients. Now we're going to take this a step further and talk about cellular respiration, which ultimately is the process in which cells convert these nutrients into energy, ATP, and waste products. And it occurs in three main stages: glycolysis, the Krebs cycle, which is also known as the citric acid cycle, and the electron transport chain. So glycolysis is the first stage of cellular respiration. It occurs in the cytoplasm. It involves the breakdown of glucose to pyruvate, and it produces a small amount of ATP and NADH in the process. So the main steps for this include glucose is phosphorylated to the form of glucose 6-phosphate. Glucose 6-phosphate is converted into fructose 6-phosphate. Fructose 6-phosphate is then phosphorylated to form fructose 1,6-biphosphate. And then fructose 1,6-biphosphate is split into 2 3-carbon molecules. Then ATP and NADH are produced, resulting in pyruvate formation. Next, we have the Krebs cycle, otherwise known as the citric acid cycle. So this occurs in the mitochondria, and it processes the pyruvate that was produced during glycolysis. It generates high-energy electron carriers such as NADH and FADH2 and a small amount of ATP. So the main steps for this include acetyl-CoA, which combines with oxaloacetate to form citrate. Citrate undergoes a series of transformations producing NADH, FADH2, and ATP. The carbon dioxide is released as a waste product, and then oxaloacetate is going to be regenerated to start the cycle again. And lastly, we have the electron transport chain. So this is the final stage of cellular respiration. It occurs in the inner mitochondrial membrane. It involves a transfer of electrons from NADH to FADH2 to oxygen, driving the production of a large amount of ATP. So the main steps for the electron transport chain include: number one is NADH and FADH2 donate electrons to the electron transport chain. The electrons are passed along a series of protein complexes. The energy released pumps protons across the membrane, creating a new protein gradient. The protons flow back through ATP synthase, driving the production of ATP, and then oxygen combines with the electrons and protons to form water. So in summary of cellular respiration, it's a vital process for energy production in the cells, and it involves the three stages of glycolysis, Krebs cycle, and electron transport chain. So together, these stages are going to convert glucose into ATP, which is ultimately the energy currency of the cell, while releasing carbon dioxide and water as byproducts. So this is such an important aspect to understand. And when we look at these processes, it's really important to come back to all of the essential nutrients that are required and are involved in so many different pathways of the body to ultimately generate energy. And so if we look here just at a few, so when we look at the beta oxidation of fatty acids into acetyl-CoA, we need magnesium, we need B2. For carbohydrates, we need B1, B2, B3, B5. We need magnesium. Even as we come into the citric acid cycle, we need a lot of B vitamins, we need iron. So you can see this importance of our vitamins and minerals in this whole process. So if you are deficient or your patients are deficient in one or more of these vitamins or minerals, then you could see how it's going to affect their mitochondrial function. And so ultimately, we're trying to really optimize mitochondrial function because it's involved in so many different disease pathologies. So looking at how nutrition is really going to be vital in these biochemical processes is crucial. I'd like to finish with a quick case study to pull all of these concepts together and also show you a couple ways that you can begin to assess for nutrient deficiencies. So this was a 33-year-old female. She had been treated with a lot of antibiotics over the course of her lifetime. Specifically in the last few years, she had been treated for SIBO, small intestinal bacterial overgrowth, multiple times. So she's had chronic SIBO, has bloating immediately after meals and as well as up to 3 hours after meals. She has exocrine pancreatic insufficiency, she has type 5 stools, and she has dry skin that she's been experiencing. So we want to think of a physical exam, which this is just scratching the surface, but we can look at nails, we can look at hair, we can look at skin, teeth, tongue. So here we saw that she had a scalloped tongue, which can indicate that there's dysbiosis. There could be potentially intestinal permeability, leaky gut. There could be mild hypothyroidism and B12 deficiency. So it already gives us a lot of insight. She also had lambda fissurine. So this is the ones that are kind of looks like little lambda over here on the right. So the inadequate pancreatic and gastric cell function is typically what that's indicating. And the central fissurine. So this can be an upregulated gut-associated lymphoid tissue, mild coating of the tongue. So that can also indicate that there's some anaerobic bacteria, some potentially increased dysbiosis, potentially even candidiasis as well. And again, upon skin evaluation, she had really dry skin. So one of the things that you can integrate with your patients immediately is something called chronometer. The recommendation that I would provide, though, is that you do want to screen if someone has had either an eating disorder in the past, current, or has disordered eating. You do want to make sure that you clear that before you ever recommend this, because it can be extremely triggering for someone with disordered eating or eating disorder. But this is a great way to not only get a great nutrient analysis, but also to empower your patient to understand the power of nutrition, which is so great. So this is a free app. You can also do a paid version, but you can begin to enter all of your food, and the more accurate your patients are, the more accurate the nutrient analysis will be, of course. And it can give us these great nutrition scores of where is your patient meeting the vitamin, mineral, electrolyte, immune support, antioxidant, and so on. And you can also determine what their macronutrients, what the micronutrients are. So it's a really, really great way to get a good understanding. And so this particular patient had been trying to eat well for a long time. So her nutrient analysis was actually pretty good. However, when we looked upon a stool test, which remember, we started this whole talk with digestion and absorption and transport. And so if there are any type of digestion or absorption issues, then it doesn't matter how well you're eating, because you're only as good as what you are absorbing. So as it relates to her stool test, there was definitely dysbiosis. She had low pancreatic elastase, which we knew. She had signs of leaky gut, increased sonulence. So there was a lot going on, which would indicate that even though she was eating pretty balanced diet, she wasn't necessarily absorbing all of these things. And then looking at a NutriVal, which is a comprehensive nutrient assessment. This looks at organic acids and metabolites, and looks at how all of these nutrients are influencing multiple pathways. So remember when we looked at the Krebs cycle, and we looked at how all of the different cofactors are necessary for optimal metabolism. And so when we're looking at something like the NutriVal, we're able to see how all these different nutrients are affecting multiple pathways. And so here, she needed a lot of support in different areas, from mitochondrial function, oxidative stress, toxic exposure, methylation. So she was having a lot of issues with B vitamin metabolism, and that was so prevalent in our Krebs cycle. And so to pull all that together, I just wanted to give you a quick insight of how we can take someone's information and be able to assess them through a physical examination. We could do a chronometer and actually do a nutrient analysis. We could do a detailed nutrient assessment, such as NutriVal, comprehensive stool test. There's so many other things that we can begin to look. But all of these things can begin to empower our patients with the power of nutrition. And so the importance of nutrition goes so far beyond even what I've talked about today, but I've tried my best to cover as much as possible. So it's important for energy production. So obviously, proper nutrition is going to provide the energy for daily activities and bodily functions, for growth and development. It is especially important in children and adolescents, for disease prevention. A balanced diet can help prevent so many chronic diseases that are associated with poor lifestyle. And this could be things like obesity, diabetes, cardiovascular disease, even certain cancers. Immune function. So adequate nutrition is going to support a healthy immune system, reducing the risk of infections. Mental health is so important. It's impacting brain function, our cognitive health, our mood, our overall well-being. Cellular function. So nutrients are vital for the repair and maintenance of cells, tissues, and organs. And when we are thinking of longevity and quality of life, we should be thinking about nutrition. Is that ultimately good nutrition is going to help to contribute to a longer, healthier life with better quality of living, i.e. health span. And to summarize, digestion, absorption, transport, and cellular respiration. Digestion, remember it's beginning at the mouth where we have this mechanical and chemical digestion that starts here with breaking down the food, but it's ultimately broken down into chyme, moves into the small intestine for further breakdown with bile and pancreatic enzymes to ultimately be the site of absorption. This is where nutrients from this digestive food are absorbed in the small intestine. So we have monosaccharides, amino acids, fatty acids entering the bloodstream or lymphatic system to be transported by cells. As it relates to transport, absorbed nutrients are transported via the bloodstream to various cells in the body. Glucose, amino acids, fatty acids are delivered to cells for energy production and other metabolic processes. And then lastly, but definitely not least, is we have cellular respiration. So this is where inside the cells, nutrients are going to undergo this cellular respiration to produce ATP, our energy. This is going to include glycolysis in the cytoplasm, the Krebs cycle in the mitochondrial matrix, and the electron transport chain, which is in that inner mitochondrial membrane that's resulting in energy production, CO2, and water. So metabolism is essential for life, involving very complex biochemical reactions that nutrition is absolutely necessary for each and every step along the way. I hope you found this helpful. Thank you so much for joining me today. If it was helpful, please make sure to subscribe to our channel for more tips on root cause medicine.
Welcome to Root the Health, the best place to order, manage, and track results from over 30 different lab companies in one single place for free. It's going to take you under 2 minutes to sign up, and you can order any functional medicine lab for your client in under 30 seconds. Let me show you how it's done. So here's our beautiful interface. I'm typing in the name of my client, selecting the lab that I want to order for them, and hitting send. From there, Rupa and their amazing team handle the rest. They email the client, collect payment, and even offer an interest-free 3-month payment plan. We've also built the world's largest library of information about chronic health conditions, the lab tests that can help you find the root cause, and the evidence-based interventions that you can use to help people heal from them. It's called the Rupa Health Magazine. There, we have in-depth articles about almost any health condition you can imagine. And we give you step-by-step protocols that other clinicians have used to help their clients heal and that are verified by evidence-based sources. You should totally check it out, and it'll transform your practice. And we can't wait to see you. So make sure you sign up today at rupahealth.com.